to conclude, today we're going to have Greg Jones, who is going to share his view on how the climate is shaping our future. Greg, thank you for being here.
Thank you, Thibaut. Can you hear me okay? Okay, good. I really appreciate being here. I was here last year. I'm going to try to encapsulate a little bit about what I did last year in terms of conversation. But I do want to say that I gave this title to this talk, I think to Thibaut back in late November when El Nino wasn't doing very much. And lo and behold, I show up today. So anyway, we should all applaud the rain. Good, good. So if we carry this back to last year, in January, February, March, I talked to Idaho, Washington, Oregon, California, different industries, and I tried to at least put some perspective on kind of what we're potentially seeing out there. And last year about this time, I talked a little bit about how the Pacific drove a lot of our climate variability, and that how the North Pacific and the tropical Pacific worked in unison to do that. So we described all those influences, and lo and behold, they definitely played out. The North Pacific was actually a much bigger driver of things this past vintage than I think most of us would have thought. I also said about this in this same talk last year that the El Nino of 2014-15 was going to be a dud, and it was. It went away and never occurred. We also said that it was going to be a warm winter and spring. That happened. I said it was going to be a dry winter, spring. We ended up having enough rain in March to really kind of get us into the growing season, I think, pretty well. So that didn't hold completely. But then I did say that the 2015 growing season heat accumulation was going to be warmer than normal and likely end up being somewhere between 2013 and 2014. And lo and behold, it ended up doing that. Now, I didn't do quite so lucky with my Powerball ticket. But, you know, some of these climate mechanisms that are out there, we can read them pretty well, and there's a lot of good information. I'm going to try to go through and at least talk about that a little bit today in terms of what we know and what we don't know. First of all, this map here, you guys have seen a lot of these out there, people looking at ocean temperatures and defining different things about it. The media has played a role in kind of getting this information out there, sometimes in good ways and sometimes in completely wrong ways. But we also have been seeing a little bit of an interest from Hollywood to make a movie on the Blob, the Son of Blob, and Godzilla. Oh, that wasn't a big enough laugh for that. Thank you. Thank you. Seriously, when looking at this was a map from back in September of last year, and we really did have some very warm ocean temperatures throughout the Pacific. And there's some interesting characteristics that played out with that, with the vintage, and we'll show you that here in just a little bit. So what I'm going to do in terms of my talk is try to put it in perspective, 2015 globally to regionally, look at our current conditions out there, talk about what I think that means for the 2016 vintage. So when we look at global temperatures from 2015, this is a map looking at January through November. We haven't had December's global data released. It's supposed to come out on Thursday. So we have to hold this meeting a few days later next year so they can get the data out. But anyway, if we look at some of this information, you can see large-scale areas were warmer than normal across the globe. And there's a very interesting thing going on in the North Atlantic right now. The meltwater coming out of the Arctic Ocean is filling in over the top of warmer water in that zone right now, producing really pretty much the only place on the planet that's colder than normal. And some people are really looking at that as potentially a mechanism which has kept Europe's climate a little cooler than it would have been otherwise the past couple of years. Trends have continued. The first 11 months of 2015 have been the warmest on record, 1.6 degrees Fahrenheit warmer than average. It beat the record set last year by 0.25 a degree. December data will, as I said, will be released on the 20th, and there's no chance statistically that it will change the record. So 2015 will be the warmest global temperature on record. Continued ocean warming throughout pretty much all oceans have really contributed to that, and I think the onset of El Nino was all part of that. If we go to the United States, we do have data that's been released for the US at a more statewide to regional level. And if you look at January through December, the way this data is put out there is that it puts a number on it to rank it out of 121 years in the data record. And you can see that Washington, Oregon, and Montana were all the warmest year on record, while California was the second warmest year on record. But you can see overall the entire United States was very warm, and lo and behold, the continental United States was 2.4 degrees Fahrenheit warmer than average in 2015. It was the second warmest year overall for the United States, and the 19th consecutive year above average. If we divide this out and go look at maximum temperatures, I know there was some conversations earlier today about talking about heat spikes and minimum temperatures, and there are some differences. Maximum temperatures were much warmer than normal throughout pretty much most of the West. But if you look at this, it was mostly tied to intermediate values of maximum temperatures, not extreme heat spikes, so it's a little bit different kind of framework for the US as a whole. But here's the big one. Go to minimum temperatures. Minimum temperatures were the warmest on record throughout the vast majority of the West, except California missed it by 1 year. And this is really due to the fact that the North Pacific, the blob and the Sunna blob were much warmer than normal. And I think that we are still kind of in somewhat of a framework to see that again this coming year. One thing I'd like to say is that clearly when you have warmer nighttime temperatures, that means something different to any plant growing. And so we have to consider these day-night differences in terms of how it presents itself. If you put California in perspective, and I just did growing season, in this case I did April through September, but I could have done March through September as well. The numbers are the same. There's roughly about a 2-degree warming over the past century, and you can see that 2015 was just below 2014. And you can see the regional differences in California do show out, somewhere between about 1.5 to almost or 3.1 degrees warming over the past 100 years or so in California. And I showed this diagram last year again, putting it kind of all in a bell-shaped curve distribution framework. Since 1995, only 99, 2010, and 2011 were below the mean. And for perspective, 2010 was about 1.7 standard deviations below the mean, whereas 2015 was very close to 3 standard deviations. 2014 was just slightly further to the right in that distribution. Go to precipitation. There's some irony here with this. If you look at statewide precipitation ranks throughout the country for the entire year, you can see the vast majority of the country was relatively wet. California, parts of the West, and lo and behold, Connecticut and Rhode Island were all quite dry. Interestingly, when you look at it from the United States perspective, we were actually above average. As a country, we were 4.5 inches above average for the continental United States in 2015. It was the third wettest 121-year period in record. This is why when you talk to somebody back east and they go, "What, it's dry out there?" That's what they're talking about, because the rest of the country was pretty darn wet. And when you look at drought, the entire continental United States drought footprint decreased by 10% in 2015. It's decreased some more since then, but this is what's happened in 2015. I also have some colleagues back in work out of Asheville, North Carolina with NOAA that put together a climate extremes index quite a few years ago, trying to kind of measure where we are in terms of high variability in climate factors. And this is the map showing most of the United States was either much above average or the highest ever in terms of climate extremes. And you can see the trend structure there. What we saw is that maximum temperatures, minimum temperatures, and one-day precipitation totals all went up throughout most of the United States. One-day precipitation totals were more in the south and southeast in Ohio Valley, but it's still, we're seeing more rain in those heavier one-day events. The Northwest and the West had elevated extremes both for maximum and minimum temperatures. We saw that especially with minimum temperatures and the spatial extent of drought in the West. The Northwest had its highest index value ever, and the West had its second highest ever. So if we go to look at some current conditions and need to describe kind of what's out there right now, this is something you've probably seen in numerous media outlets, looking at a typical kind of structural way in which we think El Nino plays out during the winter. Largely, we've seen some of this, but it really has actually been quite different in some ways as well. The split flow of the jet has been a little bit different. The northwest part of the United States is much wetter than we would have ever expected it to be during an El Nino, and that's because the jet stream had been much further north. And also the split flow of the subtropical jet has been a little further south. So there's been some differences up until this point. As a matter of fact, most of the storms that have come in so far this winter have all been North Pacific oriented. So they really haven't been El Nino storms as the kind of the media likes to play out. They've been slightly juiced by El Nino. Can't you tell today? The humidity levels in the air today was what, it's probably, what's the temperature out today? About 60 or so? And I bet the relative humidity is much higher than we normally have this time of year. And that's because we're finally tapping into more subtropical kind of moisture. When we look at the western United States, in a typical El Nino, this is what happens. We typically are warm and dry north of the Oregon border, up into the Pacific Northwest and Canada, and we're typically warm and wet to the south. There's this transition zone in between, happens to be right about where I live. In some years, it typically moves further north or south, just depending on some of the other dynamics that are going on. But what we've seen is this. Temperatures so far, and this is water year, this is going from 1st of October through just the other day, temperatures are not completely following the pattern we would have expected. All of the green that's down in the desert southwest and parts of California showing cooler than normal temperatures has never happened in an El Nino period before. It's never been quite that cool. And then everywhere else is pretty much closer to normal except for that area. We look at precipitation amounts at lower elevation areas. They're a little bit mixed. I was talking with somebody earlier, Luis, we were talking about Fresno having one of the wettest periods on record. Well, it clearly does. You can see the bullseye there. But it's mixed across most of the areas of California and even up in the Pacific Northwest. Some places much higher than average rainfall since the water year started. Others pretty low numbers to this point. Snow water equivalents put out by the National Resource Conservation Service just recently released show we're way above normal. Everything in blue there is showing high snow water equivalent numbers. As a matter of fact, there was a storm just in Oregon the past few days. Somebody measured in 5 inches of rain, they had about 1.9 inch, or 5 inches of snow, 1.9 inches of rain content in that snow. Heavy, heavy wet stuff. And that's typical when we have a southwesterly flow and more tropical air. The drought monitor, I don't know how many people look at this, but this is that picture of kind of what categorizes drought within the United States, what it looks like spatially. Most of the country has kind of made up their drought numbers. We're still kind of hanging here in the east or in the west. And if you look at just the west, I think there's some good news in here, especially when you go over to the table on the right-hand side and look at these two red boxes. Since the start of the water year, we've had anywhere from 10 to 20, 25% decrease in some of the major drought declarations spatially. There are some places that are still pretty extreme, but I think the next release of this, which will be this coming Thursday, Friday, will probably show this map to look quite different. We can also look at California reservoirs. I live in Oregon. We have the same thing for Oregon, but looking at this right now, can't see that. I don't know why that ended up like that, but the reservoirs are running 49% of historical average in terms of what they're holding right now in California, or at least with this collection of reservoirs. We need much more inputs of rain over the rest of the winter to kind of make some of this stuff up. And today, what came through is going to be very helpful. But we also need continued snow accumulation throughout the spring to provide water later into the summer, and management of all the capacity issues in these reservoirs and the releases are going to be extremely important in terms of planning for this coming year. If you look at current sea surface temperature information, there's a couple of things that have somewhat changed that we need to talk about. Number one, the blob has shifted just slightly. Temperatures are not quite as warm and they don't cover quite as big of an area, but it's still there. The sun blob has actually shifted quite a bit off of Southern California, Baja, We've seen a slight cooling of those temperatures. And then the bigger red area across the tropical Pacific, which is the signature for El Nino, has already started to wane. The numbers are already showing that El Nino is on its way out, even though the effects to our climate basically will play out over the next few months. It is already on its way out. So what do we look for in the 2016 vintage in terms of kind of our perspective overall? I wanted to throw this out there just so you can know that I don't throw darts all the time, and neither do meteorologists and climatologists. We do forecasting based upon dynamics of the system, the synoptic characteristics over large areas, how things persist from one place to another and one day to another. What are the trends in the analogs? And these are the kind of things we use and talk about. Now, weather skill rates are pretty good over time and space, up to, believe it or not, 95 to 98% for temperature and precipitation. We get it right. If we get it wrong when you're expecting it to be right, though, that's when we're in trouble, right? When you want to play golf or get married or do something like that. But anyway, so climatologists tend to do seasonal forecasting based upon persistence, trends, and analogs, and that's kind of what I wanted to mention. And we typically do pretty well with this. Believe it or not, we're running in the 65 to 75% seasonally adjusted, kind of being pretty much spot on. So let's talk a little bit about what's out there. NOAA currently has their 90-day forecast for February, March, April out, indicating an increased likelihood for a warm spring over the west. The probability holds even as we move further into additional 90-day periods to March, April, May, and beyond. When we look at rainfall patterns, this is really being driven all by what we think El Nino is going to give us in the latter part of the spring with a little bit more subtropical moisture. February, March, April indicates an increased likelihood of a dry Pacific Northwest. We've been very wet to date up north, and a wetter southward area depending on how far you go down. This shifts to kind of equal chances, wetter or drier, as we move further and further into the spring and then into the summer. The U.S. Drought Monitor has actually gone to their outlook for the coming period to show that they think that drought is going to remain throughout much of the western U.S., that kind of taupe-colored area, but it's going to improve. Some places in the north, the brown and even into that yellow area, drought development is either going to persist or become more likely. But they're actually looking pretty favorably now at getting better. There's also an update coming January 21st from that organization. So summary forecast real quick. Continued warming. Clearly 15 was warm. I think that the dynamics of what we're seeing out there in our climate system between the atmosphere and ocean are going to show us that persistence will carry into 2016. So we should have another warm year. Whether climate and extremes are out there, clearly we've been measuring them more and more, and I think that this idea of day-night temperature extremes are probably going to be with us for a while. Effects of El Nino are occurring as expected in the eastern United States, Texas, South America, Australia, Oceania, Chile. It's been very normal. We've been a little bit abnormal in the western United States up until just recently. Currently producing much more typical patterns that I think that we would expect. However, the sea surface temperature conditions in the tropical Pacific are starting to wane, and El Nino will go away probably by midsummer. So final forecast, Western U.S., I think I've already said this, transition from El Nino to neutral conditions in the tropics. North Pacific sea surface temperatures, or the blob, will likely stay warm. Taken together, California will likely be warm, wet, late winter into early spring. Pacific Northwest will stay warm and then transition to dry during that same time period. During these years, if you look at analogs, spring frost frequency tends to be much less in these type of springs. Potential for continued drought relief is out there, but might have moderate recovery, but we've got a long way to go. And all of our models, all of the analogs, everything that I've been looking at for months is kind of pointing me to pretty much the same place we were last year. 2016 should have heat accumulation that pretty much follows on the heels of the past 3 years, and it's going to end up somewhere in between all three of those. So overall, that's it for me. Thank you very much for your time. Appreciate it.
Thank you. So we have time for a few questions. Malek. Thank you.
No question.
What is the intensity of this year's El Nino, I'm using this advisedly, foretell about, say, 18 months out? Do you have a stronger possibility of La Nina conditions, or what's your view on that?
First of all, how are you doing, David? Good to see you. Yeah. So we have a tendency to see the tropical ocean kind of slosh back and forth like a bathtub. And so typically when we get this warm water movement and occurrence further to the east off of South America, it typically will flow backwards over the next 18 months or so, which if that movement, the ocean mass movement, along with the airflow above it, if it's strong enough to push real hard, then we're likely going to flip right into a La Nina. We have to see kind of the next 3 to 4 months of that, how rapidly the temperatures change within there, within that sector, and then how much the circulation of the atmosphere tends to want to push it more toward the west. But you would think we would from all of the data. Okay, looks like we're good. Thank you very much.